Next. So dito, lumipat tayo with the continuations of our lesson. We had here, in grade 8, the learners need to trace the development of the periodic table from observation based on similarities and in the properties of elements. Okay. Tingnan natin. Mabuti. Next, learners also need to use the periodic table to predict the chemical behavior of an element with emphasis on first one. Una natin is bigyan nga ako ng masigabong palakpakan. Yes. That is development of the periodic table. Another one is arrangement of elements and reactive and non-reactive metals. Yan ang ating lesson na susunod. Next, meron akong mga questions dito. This question will serve as a basis for the discussions of our lesson. Una, nako. Questions. Number 1. What basis did Dobereiner use in developing his periodic table? Also with Newlands and Mendeleev. Pangalawa, what were the demerits in Dobereiner's periodic table? How about for Newlands and Mendeleev? And pangatlo, according to Mendeleev, what do you call the horizontal rows in the periodic table? What about the vertical columns? Next, dito, let us continue our lesson with historical development of periodic table. Okay. Si Ma'am talaga nakaraan na. Binabalikan pa.
We all know that matter can exist in the form of elements, compounds, and mixtures. When elements were discovered, a proper classification was required for their easier and better understanding. Many scientists adopted different ways to classify them. They tried to find out some pattern or regularity in the properties of elements. The first among them was Johann Wolfgang Dobereiner, a German scientist who in 1829 found some groups of 3 elements which showed similar properties. These groups are called as Dobereiner triads. Here, if we have a look at triad table, we can see that the atomic mass of the middle element is approximately the mean of the atomic masses of the other 2 elements. As this classification was a primitive step, Dobereiner could identify only some triads from the elements known. Other triads did not obey the rule. Hence, the system of triads was not useful. After the failure of Dobereiner's triads, the next attempt to classify elements was done by British chemist Newlands. By this time, 56 elements were discovered. He arranged all these elements in an increasing order of their atomic masses and found that every 8th element had properties similar to that of the first. He compared this to the octaves found in music, and therefore this classification was known as Newland's octaves. However, This classification had its own share of shortcomings, the main points being that Newland could arrange elements only up to calcium out of the total 56 elements known, after which the elements did not show similar properties. Also later, several new elements which did not feature in Newland's classification were discovered. After the failure of Newland's octaves, Dmitry Ivanovich Mendeleev, a Russian chemist, put forward a periodic table that was called Mendeleev Periodic Table. Mendeleev examined the relationship between the atomic masses of the elements and their physical and chemical properties. He believed that atomic mass of element was the most fundamental property in classifying the elements. He arranged the known elements in the increasing order of their atomic masses and their properties, and thus created the first periodic table containing 63 elements, till then known as Mendeleev's periodic table. Mendeleev's law states that the physical and chemical properties of elements are a periodic function of their atomic masses. In the Mendeleev's periodic table, the horizontal rows in the periodic table are called periods. There are in total 7 periods. The vertical columns in the periodic table are called groups. There are 8 groups, numbered from 1 to 8. Mendeleev kept some blank spaces in this periodic table. The vacant spaces were for elements that were yet to be discovered. He named them Eka boron, Eka aluminium, and Eka silicon, and also predicted their properties, which later were found to be correct. When noble gases were discovered, they were placed in Mendeleev's table without disturbing the position of other elements. The Mendeleev's periodic table, however, had its own demerits. Firstly, no fixed position could be given to hydrogen in the table, as it resembled alkali metals as well as halogens. At certain places, an element of higher atomic mass has been placed before an element of lower mass. For example, cobalt, whose atomic mass is 58.93, is placed before nickel, whose atomic mass is 58.71. Also, some elements placed in the same subgroup had different properties. Example, manganese, Mn, is placed with halogens, which totally differ in properties. Due to these irregularities, a need for a new classification thus emerged. In 1913, Henry Moseley, an English physicist, discovered that atomic number is the most fundamental property of an element and not its atomic mass. This discovery changed the whole perspective of elements and their properties. Accordingly, Mendeleev's periodic law was modified into modern periodic law, which states that the chemical and physical properties of elements are a periodic function of their atomic number. The periodic table based on modern periodic law is called Modern Periodic Table. Many versions of this periodic table are in use, but the one which is most commonly used is long form of Modern Periodic Table. We shall now learn in detail about the Modern Periodic Table.